So let's spend this topic talking about the idea of vertical asymptotes. And it's already come up a couple of times in this class, but we can tell whenever a function has a vertical asymptote really just by looking at what happens when we use direct substitution for that particular value. So let's consider the function f of x equal to x minus 5 in the numerator divided by x squared plus 2x minus 35 in the denominator. And the value that I want to look at this first video here for this topic is what is the behavior of the function at x equals to -7. Well, if I use direct substitution, I get -7 minus 5 in the numerator, which is -12. I get, let's see, that becomes positive 49, -14, -35. I get 0 in the denominator. And that's the result we were looking for a vertical asymptote, is I get a non-zero result in the numerator divided by a 0 result. And one of the things that I would say is make sure you don't say things like divide equals 12 divided by 0, because that's not what it actually is. We're just using this idea to describe what's happening. So the way we want to articulate what we just said, rather than saying equals -12 divided by 0, let's say that direct substitution gives -12 in the numerator and 0 in the denominator. And I know you might look at that and think, well, why can't I say that equals -12 over 0? And because -12 over 0 is not a thing. So if I say this, it's articulating that it kind of takes the form of something divided by 0. And that's enough for us to be able to say that we know that f of x has a vertical asymptote at x equal to -7. This right here articulates the idea of a vertical asymptote. Now you might look at this function and say, hey, I know that that's going to factor and I've got another value that I want to address. And we'll do that in the next video, but we can definitively say there's a vertical asymptote at x equals -7.